everybody, welcome back. All right, so we need to review a little review before we keep moving forward in our studies. When we're talking about routing protocols, yes, the routing table, if you're going toward a destination that has, let's say, more or less the same 3 octets, but the prefix is longer, okay, it'll choose the longer prefix. But also, and that's part of your CCNA exam, but another thing that's going to be part of your CCNA exam is choosing the right routing protocol. So what we're going to do in this particular lab, which I've already configured right here, the 192.168.1.0, the 1.1 is going to be the gateway for, or the 1.1 is the not the gateway, but the actual IP address of the host, and the 1.254, as usual, is the gateway. The same thing goes to this computer, and then you have a 10.1.4, which is, this is 5 and 6. This is the 8 network, 9 and 10. This is the 12 network, 13 and 14, using a 30-bit mask. So those already have been done. And let's take a look at the routing table right now before we actually start putting in the routing protocols. Because one of the biggest things is that you need to know how to read a routing table. And you have your legend codes, which is also part of your test, which is hilarious, but anyway. Legend codes, this is what it's called. That's L is local, C is connected, S is static, R is RIP, you know, whatever. D is EAGRP, O is OSPF, and so forth. All right, so here, what do we see? We see connected, and we see local. Now, you see that you are going to notice that you're connected to the network 10.1.4 using the proper mask, which is a CIDR 30. But it's showing you that the actual IP address of this particular interface is 10.1.1.5 using a 30, masking the whole IP address as 32 bits. All right, so that's what it's telling you. You're directly connected to the G01. Here you have another one because you are connected to 3 different networks, right? The 4, the 12, and the 1.0. That is the 4. Here is the 12. And here is the 192.168.1.0. Okay, connected to that, and that is the IP address. So right now we don't have any connectivity. If I wanted to ping all the way across, it's not going to happen. Let's not go to the terminal. Let's go to the command prompt. And we're going to ping. There's an I in there somewhere. 192.168.2.1. All right. And it says destination host unreachable. You're getting a reply back from your own gateway because it doesn't know. This router doesn't know how to get to where it needs to go. So what we're going to do is we're just going to do 3 really simple routing protocols, the very basics of it. First, let's do RIP. So let's open up router 1, config T, router RIP, small keyboard, version 2, version 2, and then you say network or net, and then you actually tell the networks that you're connected to directly. So the 192.168.1.0. Now, since we're using a distance vector routing protocol, and you see that you have 10 and a 10, RIP, since being a distance vector routing protocol, does not understand that you've subnetted this particular class of address. So all you need to do is put in the class full boundary, network 10.0.0, and being distance vector, you must type no auto summary to make sure that summarization is disabled, turned off, whatever you want to call it. Do WR. With the newer EIGRPs and obviously OSPF, that's not the case. All right, so let's keep going. So that's router 1. Let's go to router 2. Let's do the same thing. Okay, enable config T. Sorry, I got a little cough. All right, router RIP, version 2, network, and then we have, well, it's just 10, so 10.0.0, no auto, enter, do WR, beautiful, and then we go to the last one, config T, and then we do router RIP, small keyboard again, sorry about that, version 2, and then we're going to do network. Now here we have really 3 networks, but we have the 192.168.2.0 network, but then we put in the classful boundary for the 10, and then we can't forget no auto. Did I do no auto on router 2? I don't remember. No auto summary. Let's go back to router 2, make sure I did. Okay. And yes, I did. All right, so let's take a look at router 1 now. All right, let's fast forward through time. That's one of the things I like about the packet tracer. Okay, you can fast forward through time. Let's do a show IP route this time. So now let's make this wider so we can see it nice and pretty. So now it's telling you, let's say your destination right here, really this is our destination network that we want to get to, is the 192.168.2.0. The administrative distance of RIP by default, which can be tweaked, is 120, and you're 1 router hop away. It's going via the 10.114. That's what it's telling you. That's how it's getting there, via the 10.114. It chose to go this way, the 10.114. There is no other way that it's choosing to go to. You're not doing any load balancing or anything like that, right? Another command that you can type, show IP protocols, okay? And you can see right there, routing for networks. You're seeing version 2 that you're sending, and you're receiving version 2. These are little checks and balances that you want to do. Summarization is not in effect. That's why we typed the no auto summary. This is where you check this. So let's see if we can get to where we need to go. So we go to PC0, and we're going to ping. Let's just up arrow, and now we're able to ping. But we're able to ping because we're going. We have a routing protocol, and we're going straight across. All right, so now let's add EIGRP. Even though this is not going to be part of your CCNA, okay, you need to know EIGRP. They talk about very little things on EIGRP, like the K values and the math, which you're not going to be doing any freaking math in the CCNA. You need to learn how to configure the protocol. That's what you need to do. Because when you go back to work, hey, I'm CCNA certified, but I can't configure EIGRP. All right, very good. Well, if I was a CCNP, they don't teach you there either. All right, so you gotta wait to get your designation, your CCNP designation. But now it lasts. All right, so we're gonna do router, EIGRP 100, and then we're gonna do network. So this is router 1. So now it's just slightly different. Let's just do net. So we're gonna do 10.1.1.4. You tell the exact mask. This is not a distance vector routing protocol. It's an advanced distance vector routing protocol. All right. We can use the wildcard mask here. So we're going to do 0003, and we leave it at that. And then we're going to do network 10.1.1.12 00003, and then we do our LAN, which is going to be 192.168.100.0 000.255. So those are the 3 networks we're connected to. Now you see I didn't type any no auto summary. Let me show you why. Show IP protocols. Cool. And then one of the things that you see, by default, due to the iOS, this is disabled. No longer do you have to type no auto summary. Many moons ago, even with EIGRP, you had to type no auto summary. Now with the iOS 15 and above, you do not need to do that. Cool. All right. So let's continue on. All right, we're gonna do exit out of here. Small keyboard. Gotta hate small keyboards. Router, EIGRP 100, network. So there's only 2 networks here, which are the top networks. Okay, net 10.1.1.4 0003. See, we build a new adjacency, which is good. Up arrow, and then we'll do the next one. Same mask, different network, which is the 8 network. And done deal there. Okay, oops, Control Shift 6 gets rid of that. Up arrow, and then we do WR, and I was gonna do it again. All right, and then Control Z, and then let's go to router 3. All right, let's exit out of that. My God. All right, router EIGRP 100, and that is the autonomous system needs to be the same. Later on, much later on, you'll start doing multiple autonomous systems in the EIGRP, but that's redistribution. That's a whole nother story. For the CCNA, single autonomous system, you're good to go. All right, network. That's going to be the 10.1.1.8, 0003. Oops, 03. There's our adjacency. Lovely. I'm just going to up arrow, change that to a 12. Right? Work smarter, not harder. Network 192.168.2.0, 000.255. Enter. Do WR. So if we did everything correctly, all right, let's go back to router 1. All right, let's fast forward through time. And then let's just bring this all the way out here. And let's take a look at it. Show, I can use up arrow, couldn't I? There we go. So show up your route. So now you see the R disappeared and you have a D in its place and instead, right? So you have, that's EIGRP. And you can see the administrative distance is 90. Before, RIP was using hop counts in order to get to where it needs to go, because RIP only cares about the closest router to it based on hop counts. Oh, it's got to get, I'm directly connected to it, well, I'm going this way. It's only 1 hop away. All right, if I got to go 2 hops, that's too long. No, I don't want to go that way. EIGRP does not do that. EIGRP uses K values, which you need to know for your CCNA. The default administrative distance is 90. Now, notice one thing that EIGRP didn't, RIP didn't do by default. Look at this right here. 2 ways. It's load balancing because it's fast Ethernet, has the same values, right? The same K values. It calculated the same reported distances, right? To get to where you need to go. So it load balanced across both the top and the bottom, the 6 and the 14. And these are considered successor routes. And you will learn that. But here's our destination network. Still only one way to go. Only one way to go. And if you wanted to look a little bit further, we're not going to get to too much detail. This is not the video for it, but just to show you, show IP EIGRP topology, TPO, LO, tab. Okay, you can see here that there is no feasible successor. There's only a successor route, meaning there's only one way to go. This is it. This is the quickest way to get, which is straight across. We don't have a feasible successor. It didn't create one. Topology table is important, but we're looking for connectivity. It's using EIGRP. It has a lower AD. In this case, the reason why it's a lower AD. Now, all these things can be tweaked, obviously, so be careful when you're taking your exam that they don't trick you. They put something like this, but they tweaked the RIP routing protocol with a lower AD. Always look at the AD number, okay? Always look at that. So let's ping from the PC, shall we? Like we did before. Here we go. And we have connectivity. Now, obviously, we're using EIGRP. So lastly, let's do OSPF. So we're going to do router OSPF1 in privilege mode, obviously. Up arrow, get rid of 1 T, not 2 T's. Router OSPF1, which is the process ID number, doesn't matter. Okay, it's local to the router. And then we'll do network. And then we'll do the 10.1.1.4, 0003, single area. Area 0 is the backbone area, so that's the one we're going to put. And then the next one will be 12, which is going underneath, right? So these are the 2 areas that we, oh, and the third area, which is the LAN, haha, network, okay? It's 192.168.1.0. 000.255 area 0. Okay, cool. That's done. Now this is single area OSPF. Single area. The default administrative distance is 110. Will it take? It should not. It should not. But we'll find that out, won't we? Router OSPF 1. And again, process ID number doesn't matter. You can put whatever you want. It's local to the database. Why we always use 1? So we don't have to use another number, because if you need to retweak it, you need to go back into the same process ID number. So not to make any mistakes, we just use the same one. network 10.1.1.4.0.0.0.3 area 0. Now this takes a little bit, and OSPF will come back with their neighbor relationship, okay? But it always gets me. But there it is, full loading done. There you can see your OSPF 5 adjacency change, right? So that's what you want to see. That's a good thing, all right? I'm going to up arrow, and then I'm going to put 8, right? Work smarter, not harder. Cool. Done with that. And now we're going to go into router 3. Let's exit router here. And we'll do router OSPF 1 network. Let's do the 210s. 10.1.1.8 0.0.0.3 area 0. All right, and then we're gonna up arrow again and change that to a 12. And we should see some adjacency sometime today. Okay, network, there it is. Wow, I'm working faster than the protocol. 192.168.2.0 0.0.0.255 area, oops, area 0. There we go, WR. All right, so now let's go back to router 1. Let's fast forward through time, right? Let's go ahead and make this wide so we can see a nice routing table. Control Z, right? Clear all that mumbo jumbo. Show IP route. So now we see, see this is a problem here. We see D and D. Well, why is that? What's going on there? Well, because by default, EdgeRP uses 90. All right, and this is the kind of things you're going to look at in your test. It's not just about the longest prefix. Yes, there will be a question on using the longest prefix, definitely. All right, it'll choose that first. But if it's not the longest prefix because you're not going to some similar network, right, that they're using 24, 26, 28, 32, all right, it's 192.168, 1.0, 24, 26, 28, 30, it's, you know, that one question, all right? They'll mess with you when it comes to writing protocols. So OSPF, I said it, the default administrative distance is 110. So how do we fix that? So that's your lab. You better hope you know how to fix that because the weight is in the lab. So you're gonna go in here, config T, right? You're going to that process ID number, router OSPF 1, and then you're gonna do distance something lower than 90. I just pick 50. It's a number I like to use. Okay, well, not really. I like to pick 40. Not that it really matters. As long as it's lower than 90, you're good to go. All right, let's minimize that. Let's go to router 2. We're inside OSPF still. Distance 40. Do WR. And then router 3. Distance, oops, we're not inside OSPF. Config T. Router OSPF 1. Distance, okay. Jeez Louise. 40. Do WR. Okay, let's minimize this. Let's fast forward through time. Alrighty, that's enough. Let's go ahead and take a look and see what we got. Let's make it wide. Enable. Show IP route. And now we see O's. Now we see O's. And you can see the load balancing that's going on here as well. OSPF does that also. It's a link state routing protocol. All right, it's based on cost. This is not a hop count, this is the cost. But look at the administrative distance. That's what I put, 40. I didn't want EdgeRP. And here is the destination network that we want to reach. All right, we have a lower administrative distance. That's the cost value. The lower the cost, the better. The higher the cost, the slower. So we're going to go ahead and ping. And I'm shooting all barrel. And there we go. But now we're using OSPF. So the whole point of this lab is to show you that yes, your normal routing protocols, right? RIP, RIP version 2, EIGRP, and OSPF, they have their default administrative distances. And if that's what the question is asking you, because you gotta really look at the question, which routing protocol would make it to the routing table, if that's what it's asking, you're gonna say EIGRP because it's 90. But be very, very careful. They can turn this into a scenario-based question or lab scenario where you have to do what I just did, where you have the 3 routing protocols and OSPF should be the routing protocol that you want to be using, and it's not because of its default administrative distance of 110. You need to change that to something lower than 90, and you're just go inside the process ID number and say distance 40, distance 50, distance whatever. As long as it's slower than 90, you put 89 if you wanted to. Okay, so that's it. It's very simple, very easy. It's just a matter of reading, looking through what they want you to do, okay, and understanding the concept of it. So it's very something simple. Just practice it and you do just fine. Okay, remember this is a CCNA. It's not, they can get tricky, but they're not gonna get silly. You only have 90 minutes to get this done. All right, I'll see you in the next one.